I'm Tom, coming to you from the International Institute for the Advancement of Sourdough Science and Research of Cleveland, Ohio, also known as my kitchen. Thank you for selecting this video. In today's video, we're going to talk about one of the biggest challenges sourdough bakers have, and that is trying to figure out when do you cut off bulk fermentation. This is the most challenging aspect of sourdough baking. I've done dozens of videos on this topic, and people still continue to struggle with it. Now, if you look at the most popular recipes that are out there, many recipes will give very simplistic guidance that says you mix your dough, you do your stretch and folds, and then you let your dough rise at room temperature until it doubles in volume. What I'm going to show you in today's video is that guidance is completely wrong. I've done a number of experiments over the years, and I've proven that the percentage rise in bulk fermentation that you're looking for is related to the dough temperature. Warm fermenting dough needs to be cut off earlier than cool fermenting dough because that dough keeps fermenting in the downstream steps. After bulk fermentation is done, it keeps fermenting in pre-shaping, bench rest, final shaping, and then when the dough goes into the refrigerator, typically for a cold retard, the dough keeps fermenting. So that ending temperature of the dough determines what happens after bulk fermentation. So you need to synchronize the percentage rise with the dough temperature. This is the biggest secret of sourdough bulk fermentation. I'm going to explain it here today. Now, before we jump into the details, I just want to reply to the people who've been asking about Brother Bob. Now, for those of you who watch my videos, you know that Brother Bob was here around the 4th of July, and we were filming the Sourdough Brothers Sourdough for Busy People video, and Bob suffered a head injury in my kitchen during the filming of that video.
Brother Tom, I'm so happy to be back.
Bob's doing okay. He's back in California. He's back at his teaching job, but Bob's having a little trouble with his memory. Bob thinks that somehow when he was here, he was involved in an Amish barn raising. I have no idea what he's talking about. But I think Bob's going to be fine, and we're looking forward to creating more Sourdough Brothers videos in the future. Now let me give you some background on this question of when do you cut off bulk fermentation. As people know, I've been doing research on this for years. The first time I looked into this was in 2021 when I did 2 videos in my When is Bulk Fermentation Done series, episode 7 and episode 8. And what I was looking at that time was this discrepancy between recipes where things like the Chad Robertson Tartine Country Loaf recipe that I follow religiously recommends a 30% rise in the dough in bulk fermentation, and then many other popular recipes were recommending 100% rise in the dough. And I couldn't figure out how is that possible. In those experiments, I found the first glimpse into this issue that the percentage rise in the dough needs to be correlated with the dough temperature. Warm dough needs to be cut off earlier than cool dough. So in this example, I cut off Chad Robertson's recipe at a 30% rise, which is what he recommends, because the dough temperature he recommends is 80 degrees Fahrenheit or 27 degrees Celsius. That's a very warm fermentation temperature. Then I compared that to other recipes that were bulk fermenting at 70 degrees Fahrenheit or 21 degrees Celsius. Those could tolerate a much higher percentage rise in the dough, and I was able to produce the exact same results at the end. So I continued doing experiments, and in January of 2023, I published this article, The Mystery of Percentage Rise in Bulk Fermentation. You can find this on my website, and you can find this in the description of the video. This was really a breakthrough where I put all the science together, and in this document, I published this table, which I had proven through multiple experiments that shows when you bulk ferment at warm temperatures, you need to cut off the dough earlier. When you bulk ferment at cooler temperatures, you can go for a higher percentage rise. So what you can see on this chart is if your dough is bulk fermenting at 80 degrees Fahrenheit, you cut that off at a 30% rise. If your dough is bulk fermenting, say at 70 degrees Fahrenheit, the third line here, you cut that off at a 75% rise. And the only time you go for 100% rise is if your dough is very cool. Lower than 70 degrees Fahrenheit or 21 degrees Celsius. In my experience, it needs to be around 65 degrees Fahrenheit or 18 degrees Celsius to tolerate 100% rise in the dough. This chart has been cut and pasted out of my document and shared tens of thousands of times on social media. This is the most shared piece of content on social media right now around bulk fermentation, really around sourdough baking in general. Everybody is sharing this content because this is a breakthrough. It refutes the general guidance of just let your dough double at room temperature. If you do that, generally speaking, your dough will overproof. And I've seen this in many, many examples, hundreds of people overproofing their dough every month because they're following the simple, simplistic, and inaccurate guidance of just letting your dough double. So now you might be asking the question, how does this actually work? Here's how it works. You mix up your dough, and when all the ingredients are initially mixed, you're going to put that in a measuring vessel, and you're going to measure your starting volume of dough. Then you do your stretch and folds, you let your dough rise, and as the dough is rising, you take the temperature of your dough. My dough is at 70 degrees Fahrenheit, 21 degrees Celsius. So I consult my handy chart that says at 70 degrees Fahrenheit, 21 degrees Celsius, I'm looking for a 75% rise in the dough. So I take my starting volume, I multiply that by 1.75, and I put this second marker on my measuring vessel, and I wait for the dough to hit that percentage rise. When the dough hits that percentage rise, it's perfectly fermented. Then I shape the dough, I pre-shape the dough, I let it rest for 30 minutes, I final shape the dough, I put it into the refrigerator, I take it out the next day, anywhere from 8 to 16 hours after it's been in the cold retard in the refrigerator, and the dough is perfectly proofed. And this works at any temperature if you synchronize the percentage rise with the temperature. Here are some examples. 80-degree dough cut off at a 30% rise, perfectly proofed. 75-degree dough cut off at a 50% rise, perfectly proofed. 70-degree dough cut off at a 75% rise, perfectly proofed. 65-degree dough cut off at a 100% rise, perfectly proofed. This method works. And what you can see is the only time you want your dough to double in volume is when your dough is very cold. In my example, 65 degrees Fahrenheit, 21 degrees Celsius. So all the guidance out there that says let your dough double at room temperature, if your room temperature is above 65 degrees Fahrenheit, which it usually is in most people's kitchens, your dough is going to overproof. So now you ask the question, how does this work? And the reason this works is because we tend to think of bulk fermentation as the end of something. I mean, we call it that, the end of bulk fermentation, but you need to think of that as the beginning of something. The end of bulk fermentation is the beginning of the rest of the fermentation process. So when you cut off bulk fermentation, that's an arbitrary point. The yeast doesn't know bulk fermentation is over. The lactic acid bacteria doesn't know bulk fermentation is over. They're just going to keep fermenting. So you cut off bulk fermentation, then you pre-shape the dough, you let it rest on the countertop for 30 minutes, you final shape it. During that 30 minutes or so, that dough is still rapidly fermenting. It doesn't know bulk fermentation's over. Then, when you put that dough into the refrigerator, it takes 10 hours for the dough to get down to the refrigerator temperature. A lot of people assume, I mean, it's easy to assume, you put that dough in the refrigerator and it just immediately stops fermenting and it goes down to the refrigerator temperature. That doesn't happen. Here's what actually happens. Take a look at this chart. If we take our 80-degree Fahrenheit dough, 27 degrees Celsius, we pre-shape it, bench rest it, final shape it, that dough temperature drops to about 78 degrees Fahrenheit before it goes into the refrigerator. It goes into the refrigerator, and for the first hour, that dough is still rapidly fermenting. It takes an hour to get down to 70 degrees Fahrenheit or 21 degrees Celsius, which is a lot of people's kitchen temperature. The dough thinks it's still fermenting at room temperature. Then, in the next 3 hours, that dough drops from 70 degrees Fahrenheit to about 50 degrees Fahrenheit, 10 degrees Celsius. That's still a fairly moderate fermentation range. There is real fermentation happening there in those 3 hours. Then the next 3 hours, the temperature drops from 50 degrees Fahrenheit to about 41 degrees Fahrenheit or 5 degrees Celsius. The dough is still slowly fermenting. And then in those last 3 hours, it drops from 41 degrees Fahrenheit to 39 degrees Fahrenheit or 4 degrees Celsius. And that's where the yeast finally goes to sleep and it starts fermenting very, very slowly. It never actually stops in the refrigerator, but when it hits 39 degrees Fahrenheit or 4 degrees Celsius, you can consider it to be very, very slowly fermenting. So now if you look at this chart, you can see what's happening. When you put very warm dough into the refrigerator, there are two things. That dough is rapidly fermenting before it goes into the refrigerator because the fermentation rate is related to the temperature. 80 degree Fahrenheit dough, 27 degrees Celsius, is rapidly fermenting. So it goes in, moving very quickly, and because it's a warmer temperature, it takes a longer time for the temperature to get down to 39 degrees Fahrenheit or 4 degrees Celsius where the yeast goes to sleep. So you get a lot of fermentation happening in the refrigerator. Contrast that with very cool dough, 65 degree Fahrenheit dough, 18 degrees Celsius. It goes in at a slower rate of fermentation because it's cooler going into the refrigerator, and it goes in at a lower point on the curve, so it hits the refrigerator temperature more quickly and the yeast goes to sleep more quickly. So the cool dough ferments much less in the refrigerator. So that's where this formula basically makes sense. You're doing the same amount of fermentation between bulk fermentation and the final proofing, but the amount of fermentation happening in bulk fermentation versus in the refrigerator is different based on that dough temperature and when you cut off the bulk fermentation. If you want to learn more about the science behind this chart, there's a link to the article in the description of this video, and you can find it on my website at thesourdoughjourney.com. So when I think about that cutoff of bulk fermentation, I think of it a lot like as if you were throwing a javelin. When you throw a javelin, the moment it leaves your hand, you have no control over what happens. That's the cutoff of bulk fermentation. Once you decide that cutoff, basically you have no control over the dough going forward until it comes out of the refrigerator. When you throw a javelin, the thing you do have control over is the speed of your hand and that trajectory of the javelin. That determines where it will land. So you can imagine for warm dough, where I'm bulk fermenting at 80 degrees Fahrenheit, but I'm doing that cutoff at a 30% rise, I have a long distance to cover. So I need a lot of speed and a steep trajectory to get the javelin to land in the right place. If I'm bulk fermenting at cool temperatures, that dough is fermenting more slowly, so my hand speed is slower, and I've already achieved a higher percentage rise, so I'm releasing it at a lower trajectory. Both of those javelins will land in exactly the same place. So here's an example of a javelin throwing competition where we have two throwers, but in this unique competition, each one of them can decide how far they want to run down the field before they stop. That's the end of bulk fermentation, and then they throw the javelin from there. That's the cold retard. So the first thrower represents our 80 degree Fahrenheit dough, which we would bulk ferment to a 30% rise. So this thrower runs down the field 30 meters towards the target, then he stops. That's the end of bulk fermentation. But this thrower has a very strong arm because at that 80 degree Fahrenheit dough temperature, the dough is fermenting very quickly. So he can release the javelin with a fast hand speed and a high trajectory, and he can make the distance to the target, doing most of the fermentation after the end of bulk fermentation. Compare that to the second thrower. He represents the 70 degree Fahrenheit dough that we would bulk ferment to a 75% rise before the cutoff. He runs 75 meters down the field. He needs to get closer to the target because he has a weaker arm. The dough temperature is only 70 degrees Fahrenheit, so he doesn't have the same hand speed or that same trajectory. So he goes closer to the target, the 75% rise, then he releases his javelin, it lands in the exact same spot. So what you can see with this example is that both the javelins travel the same distance, they just get there through different means. Part of the way is through running and part is through throwing. The running is the bulk fermentation, the throwing is the cold retard. And what you see with warm dough, the 80 Fahrenheit dough, that travels a long distance in the air. During the cold retard, a lot of fermentation is happening in the refrigerator. And with cooler dough, less of the fermentation is happening in the refrigerator, but they both land in the same place. But once it leaves your hand, you have no control over it. Its outcome is predestined once you decide that cutoff of bulk fermentation. Here's another example. Trying to determine that cutoff of bulk fermentation is like trying to figure out if you're driving a speeding car on a slippery road and you see a stop sign up ahead, when do you need to hit the brakes? That's the cutoff of bulk fermentation. And you can imagine if you're driving really fast, you need to hit the brakes earlier because you're on a slippery road and you're going to start skidding when you hit the brakes, so you need a longer stopping distance. If you're traveling more slowly, you can wait later to hit the brakes because you have a shorter stopping distance. The speed of the car is the equivalent of the bulk fermentation dough temperature. Warm dough ferments very quickly compared to cold dough. So here's a live example of the speeding car. We're going to have Santa with a couple of his reindeer in his tricked out Chevy lowrider here. Santa's going to be driving his car from the beginning of bulk fermentation. That's this blue line here. This line would be 100% rise in bulk fermentation. And then the stop sign that Santa sees ahead is this big red Dutch oven. That's after shaping and the cold retard in the refrigerator, which is represented here. And that's when the dough is going to get into the oven. So basically, you're speeding through bulk fermentation. You want to hit the brakes on the slippery road, and you're going to slide in here to stop right before it goes into the oven at the stop sign. Here's Santa. He's going to be going 80 miles an hour. That's 130 kilometers per hour. And let's assume that's the equivalent of an 80 Fahrenheit dough temperature, 27 degrees Celsius. Based on our chart, that means Santa needs to hit the brakes on the slippery road at the 30% rise mark, which is way back here, early in bulk fermentation, because he's going so fast. And he's used to driving a sleigh. This car has rear-wheel drive. It doesn't have anti-lock brakes. This is not going to be pretty. So if Santa's driving 80 miles an hour, and let's say he doesn't know about that chart, he comes flying through bulk fermentation and he does 100% rise like you read in some recipe, and he hits the brakes here, he skids out of control, there's a rollover accident, Christmas is canceled. I mean, this is the real year without a Santa Claus. This is a Christmas tragedy. So if you go too far in your bulk fermentation at a warm temperature, your dough is going to overproof. Then we say, Santa, check out the chart, dude. 30% rise. You need to hit the brakes right here. So Santa comes speeding into bulk fermentation at 80 miles an hour. Now he hits the brakes here. He goes into a skid. He's going past the 100% rise mark, and he parks it right next to the stop sign, goes into the Dutch oven, and gets baked into a perfectly proofed loaf of bread because he hit the brakes earlier, which he needed to do because he was driving so quickly. Here's another example. Santa got a speeding ticket, needed to slow down, lead-foot Santa. So now he only drives at 40 miles per hour. That's half the speed he was at before. And that's actually the equivalent of about this 70 Fahrenheit or 21 degrees Celsius temperature. That's almost half of the fermentation speed of the 80 Fahrenheit dough. It's much, much slower just in that 10 Fahrenheit difference. So now Santa's cruising along at 40 miles per hour. That's 65 kilometers per hour. He's taking his time. He sees a stop sign up ahead here. He's got a lot of safe stopping distance. So he's going to go for a 75% rise based on the chart. So he hits the brakes here. He cruises through, slides it in, boom, right into the stop sign. Santa goes into the oven and makes a perfectly proofed loaf of bread for Christmas dinner. So warm dough is just like a speeding car. You need to hit the brakes early to ensure that you have a safe stopping distance. If you want to learn more about this speeding car example, there's a link to the article in the description of this video, and you can find it on my website at thesourdoughjourney.com. Now that you understand this in theory, let's talk about how do you put this into practice. So most sourdough recipes will tell you you need some specialized tools for sourdough baking. You need a digital kitchen scale, you need a lamb, you need a banneton, you need a Dutch oven. But what they don't tell you you need is a digital probe thermometer to take the temperature of your dough during bulk fermentation, and you need a measuring vessel to measure the change in volume, which is the percentage rise in the dough in bulk fermentation. Here's an example of a measuring vessel. This is a large one. Here's a small one. There are all kinds of measuring vessels. You want to find something with milliliter or liter or quart markers on it. That's how we're going to measure the percentage rise in the dough. It's the change in volume, which is measured in liters or quarts. You can buy small kitchen storage vessels like this one. This has milliliter markers on it. This is perfect for bulk fermenting one small batch of dough. If you work in a laboratory, you could borrow one of these scientific beakers. I like to use this. That's a 3-liter beaker. I can do a 2-loaf rise in that vessel. So anything with milliliter markers on it. This is the one I showed earlier. This is what's called a batter bowl. It's basically like a bowl with a handle, but that has the milliliter markers on it as well. There are a lot of kitchen vessels out there. You need to find one of those. And the important thing we don't need is a clock. With this method, you ignore the time. You have absolutely no use for this device. Put it away, step away from the clock. No need to measure the time. Now let me go back and talk about this chart, because I've been talking about the way you do this is measuring the dough temperature and the percentage rise. And if you read the whole document, those are the two variables that you need. I show the timing on this chart just so people can understand how much longer the dough will take to rise if you're bulk fermenting at these low temperatures. But you never use the time to determine when bulk fermentation is done. The time will lie to you. The temperature and percentage rise never lie. It's impossible. It's physically impossible for them to lie. The clock will lie because certain starters will rise faster or slower than others. Different flour will rise faster or slower than others. If you have different recipes that you're using, they'll rise faster and slower. So you can never rely on the time, only rely on the temperature. So I use this chart just to show the relative time, but we are not going to use this. Ignore the time. This is all we need for the rest of the process. Temperature and percent rise gives you 100% reliability, and it's repeatable no matter how long it takes. So this is the point in the video where you might be saying to yourself, wow, this sounds so simple. How come I never heard of this before? Because most popular recipes are wrong. I don't know any other way to say it. I looked at the top 10 most popular sourdough recipes out there, and 8 of the 10 say, mix your dough, do some stretch and folds, and then let your dough rest at room temperature until it doubles in size. That is the instruction for bulk fermentation in 8 of the 10 most popular sourdough recipes. That instruction is wrong. Let's just talk about it. The first part, let your dough rise at room temperature. I mean, what the heck is room temperature? I mean, my temperature in my kitchen right now is 74 degrees Fahrenheit. If I lived in Australia right now, my kitchen temperature would be 90 degrees Fahrenheit or 32 degrees Celsius. If I lived in Finland right now, my kitchen temperature would be 50 degrees Fahrenheit or 10 degrees Celsius. So any recipe that tells you to do something at room temperature is completely meaningless because room temperature can be an incredibly wide variation. The second problem with these recipes is they say, let your dough double, which isn't a bad concept, but they don't actually measure the doubling. If you watch those videos and look at the photos in the recipes, they're using a bowl like this with their dough in it, and they show a picture that says, okay, I let my dough double at room temperature, and they show a picture of a puffed up ball of dough. That's not actually doubled. There's no way to tell if it's actually doubled. Let me say it that way. Doubling is a mathematical concept. If you went into your boss's office and your boss said, congratulations, I'm going to double your salary, you know what that means. It's 2 times your salary. That's what double is. If your child is 3 feet tall and they grow to be 6 feet tall, you would say, oh my gosh, my child has doubled in height. It's a measurable thing, unless you're a sourdough baker, and then doubling means I look at my dough and it's kind of puffed up, and if I feel like I'm ready to go to the next step, I just decide it's doubled. That's how these recipes work. But you say, but these bakers, they then show in the video the dough comes out perfectly. It's because they're eyeballing the dough. They're using other criteria that they're not explaining to you. They're smelling the dough. You can't even see it, but they're smelling it. They're shaking the dough. They're using the same bowl that they always use so they can tell if the dough is touching the side of the bowl at a specific point. But that dough, I'm telling you, is not doubling unless the dough temperature is below 70 degrees Fahrenheit, 21 degrees Celsius. Otherwise, their loaves would overproof. So it's just a lazy way of doing instruction. I don't know any other way to say it. And I hate criticizing other sourdough bakers and instructors, but telling people to let your dough double at room temperature is lazy, and it's usually wrong. Now, there are two notable exceptions. When I said I looked at the top 10 recipes that people use, look at this one. Chad Robertson, tartine bread, my favorite recipe in the world. Chad Robertson is one of the two that does provide dough temperature and percentage rise. He specifically says during bulk fermentation, the dough temperature should be between 78 degrees Fahrenheit and 82 degrees Fahrenheit. That's 25.5 to 28 degrees Celsius. And he tells you the percentage rise, between 20 to 30% rise in the dough when you cut off bulk fermentation. That's exactly where my studies came out here. For 80 degree dough, 27 degrees Celsius, you go for a 30% rise. Chad Robertson had this figured out in 2006. He told people how to do it. The other example, very popular recipe from Elaine Body. Elaine tells you, let your dough double in size, but she gives you the specific dough temperature, 18 degrees Celsius to 20 degrees Celsius, which is 64 degrees Fahrenheit to 68 degrees Fahrenheit, which is exactly what I found in my studies. At 65 degree dough temperature, which is right where Elaine's recipe is, you go for a 100% rise in the dough. Elaine's method works. And Elaine even tells you what bowl to use. She specifies this bowl. I went out and bought this, and she says if you follow her recipe and you let the dough rise up to this line below the rim, that'll be 100% rise in the dough. I actually measured this. I put it on a scale and I measured the milliliter volume up to that line. It's actually about 113% rise in the dough, not 100%, but that's well within the realm of a rounding error when you're trying to measure the percentage rise in the dough. So Elaine, good job. Chad Robertson, good job, because they told you the dough temperature and the percent rise in bulk fermentation. These are two of the most popular and most successful recipes out there, and it's not a coincidence. The other 8 people, I think you have some work to do on your instruction. And this is the point in the video where you might say, wow, this Tom guy sounds like a cranky old dude criticizing other people's recipes. Let's roll back the clock 5 years to 2018. Check out Jack Sturgis from the Bake with Jack YouTube channel. Jack is the opposite of a cranky old dude. And 5 years ago, Jack made this video called Leave Your Dough to Double? And in that video, Jack basically said, telling people to let their dough double in bulk fermentation is nonsense, and any recipe that recommends that is a bad recipe. Now, Jack did not, in that video, say the way to do it is by measuring the temperature and the percentage rise. He described the techniques for reading the dough. And this is what a lot of expert bakers rely on. They shake the dough, they smell the dough, they look at the dome, they go like this. And that baker's intuition is basically what they're using, but as a proxy, they're telling you that the dough has doubled just because that's a lazy way to describe a puffed up ball of dough that they've expertly assessed to be finished with bulk fermentation. But with this method, you don't need to be an expert. Read the chart. Temperature, percent rise, tells you when bulk fermentation's done. Now let's talk about how we actually do this, measuring the dough temperature and the percentage rise. Dough temperature is easy. You need a digital kitchen probe thermometer like this. You're going to take your bowl of dough, and you're going to put that probe right in the center of the dough. That's your true fermentation temperature. Mine's sitting at 70 degrees Fahrenheit. And a lot of people are nervous about poking their dough with this thermometer. You can poke. It's not a balloon. You're not going to deflate your dough by taking the temperature. I even do it every half hour sometimes. It has no detrimental impact on the dough by poking it with a thermometer. So I have 70 degree Fahrenheit, 21 degrees Celsius dough. The other thing I like to know is what's my kitchen temperature. So I also keep a small thermometer in my kitchen. This is at 74 degrees Fahrenheit, which is about 23 degrees Celsius, because as my dough is fermenting, if I'm not keeping this in some kind of proofing chamber, the dough temperature is ultimately going to try to equalize with your kitchen temperature. So you always want to be aware of that difference. So I know the longer this dough sits out at 70 degrees Fahrenheit, it wants to be at 74 degrees Fahrenheit. Why does this create a problem? Because if people use thermometers like this, these infrared thermometers, these just test the surface temperature of the dough. And if I let this sit here for about a half an hour, the surface temperature of the dough will say 74 degrees Fahrenheit, which is my kitchen temperature, really quickly. But the true fermentation temperature of the dough, in my opinion, is always that temperature at the center. That's what you want to use when you're looking at the chart. It's the temperature at the center of the dough. Another question people ask is, what if the dough temperature changes over time because you're bulk fermenting over a long period of time? Let's say I mix this dough at 70 degrees Fahrenheit, but it ends up at 75 degrees Fahrenheit. Which number on the chart should I use? Should I use 70? Should I use 75? Should I use 72.5, the average? The most important temperature when you're using this method is the ending dough temperature. And you know why? Because that is when the javelin is released from the hand. The ending dough temperature is what carries forward into pre-shaping, bench rest, final shaping, and into the refrigerator. And that downstream impact of the fermentation that perfectly proofs it is based on the temperature as the dough goes into the refrigerator. So if your temperature changes over time, use the ending temperature. So now for measuring the percentage rise in the dough, let's talk about the fermentation vessels. I showed some examples earlier. These are great examples because these have liters or quarts or cups marked on them. I tend to do it in liters or milliliters. That's what you want to measure the volume in. If you're doing a small batch of dough, you can even use these small Pyrex containers. Those have milliliter markers on them. I like this one. This is a 2-liter vessel with milliliters on it. You can buy all these things with milliliters on them. That's the best way to do it. Milliliters are the way that you measure the change in volume. That's the metric system equivalent of cubic inches or cups, I guess, in the US system or the imperial system. But you always want to use milliliters. That's the true measure of volume. And you want to have that accuracy, which is, it's a more accurate measurement than using cups or quarts. And then some people say, come on, do I really need to measure in milliliters? I mean, does it need to be that accurate? Can't I just use my trusty bowl and eyeball this to tell when it doubles? Let me ask you a question. If you went to a golf class and the golf instructor said, you only need to bring one thing to class, you need to bring a golf club. And you show up at the class and you say, I don't have a golf club, but I have this stick. And I really think I could play golf with this stick. They would say, that is not the tool to play golf with. You can't take the class with a stick. And then if you went to a baseball school and they said you need to bring a baseball mitt, and you showed up with, a kitchen oven glove, and it's even on the wrong hand, and you'd said, I'm good, I got my mitt here, they would say, you can't play baseball with an oven mitt, you need a baseball mitt. But with sourdough baking, for some reason, when people say you need to measure the percent rise in milliliters, people say, I'm good. Got my bowl right here. I can tell when this is double. It's impossible to tell when your dough doubles in a bowl like this. And then you might say, okay, Smarty, what about this bowl where I can actually look through the side of it? Because then I can tell the height change in this. And if the height doubles, that would be a doubling of my dough. Wrong answer. The doubling of the dough is measured in milliliters, not in height, because if your bowl flares out on the side like this, the first 3 inches of height is about 1/3 of the total volume of the bowl, and the second 3 inches of height is 2/3 of the volume of the bowl. So there's no way to measure the percent change in volume, the percent rise in the dough, using a flared out bowl like this just by eyeballing it. You can't just look at it and gauge it based on the height. However, if you have a perfectly straight-sided vessel like this, you can use this, but you need a ruler. So here, if you have straight sides on the vessel, you can measure the height, because then the change in height is the change in volume only with a perfectly straight-sided vessel. So take a ruler, put a piece of tape on here, and measure this either in inches or centimeters. I recommend doing it in centimeters because the math is a little bit easier to do. You can turn this into a measuring vessel. I do this all the time. And then some people still say, not going to do it. I'm not going to go out and buy a straight-sided vessel because I got my bowl. I just want to use my trusty bowl. There is a way. You can make any shape or size vessel into a milliliter measuring vessel by doing what I call the water trick. Here's how you do it. Take any shape or size vessel. As long as it's transparent, you need to be able to see through it. And you're going to put a piece of tape on the side of this vessel. Then you're going to put that on the scale. You're going to zero out your scale, and you're going to pour in 100 grams of water at a time. 100 grams of water equals 100 milliliters. That's how the metric system was designed. It's around the density or the volume of water. So grams equals milliliters only for water, not for other liquids. I put in 100 milliliters of water. I marked my first hash mark. I put in another, sorry, I said milliliters, it's the same, 100 grams more. Now I'm up to 200. I put my hash mark on the tape. Then when you finish filling this up to the top, you're going to pour the water out. And then using your best penmanship, you're going to write in those milliliter markers. 100, 200. That's a 2,400 milliliter bowl. That's 2.4 liters. I did not know that. And now I have another measuring vessel in my kitchen that I can use to measure the percentage rise in my dough. So now people ask, how do you measure that starting volume of the dough? What is that starting line? So the starting line is the volume of the dough after all the ingredients have been mixed together. A lot of recipes, you mix everything together at the same time. Some of them delay adding the starter, they delay adding the salt, they delay adding some water. So you want to wait until you have all the ingredients in the bowl. Once they're in the bowl, then you're going to move that into your measuring vessel to mark your starting line. So I'm going to do that right here. This is my mixed dough. It's all my ingredients in it. I move that into my measuring vessel, and I want to pat this down so that it's level. You want to do the best you can. I mean, it's dough. It's not going to be perfectly level. But you get that level, then you look through your milliliter markers on the side of the bowl, and you measure your starting volume. And this is 750 milliliters. So I'm at 750. I put a piece of blue tape on the side of that bowl where my starting volume is. That's my starting line. Now, you look at this and say, Tom, this is a little crazy. You mix the dough in this bowl, then you put it in this bowl, but now I still need to do my stretch and folds or my coil folds or whatever. What do? I take the dough out and I put it back in my larger bowl where it's easier to do the coil folds, stretch and folds, whatever. And I don't have to worry about if this starts rising in that bowl because I already know my starting line. And the other really interesting thing is, once you do this for a given recipe, it's always exactly the same. The volume of the mixed dough is the same for a recipe, so you only have to do that transfer one time. And now I know my starting line is 750. If I mix this exact same batch tomorrow or a month later or a year later, the starting volume is always 750. So write that down on your recipe card or sheet, so you always know what your starting volume is. Then you don't have to do this transfer. You just mark the bowl when you mix the dough. There's another great trick or shortcut you can use. I've done this many times, hundreds of times, where I've mixed the dough, I moved it into the measuring vessel. the volume of the mixed dough, if you're following a standard sourdough recipe with 75% hydration, 20% starter inoculation, 2% salt, it's kind of the standard recipe that you find a lot of times. That dough mixes up at 1.5 times the flour weight in milliliters. So if I'm mixing a 500 gram batch of dough, I take 500 times 1.5, that's 750. Look what number I have here, 750. It's 1.5 times the weight in grams equals the milliliters. That really works. I mean, that will get you very close a lot of the time. And again, once you validate that for a recipe, it never changes. So I use that when I'm doing my routine recipes over and over again. If I'm making a recipe for the first time, I might actually move it into the bowl and mark that starting line rather than doing the 1.5 rule. Now, related to this, some people will say, how do I know how big of a vessel I need for my bulk fermentation? Because I showed you some examples here. How did I decide whether I was using this small one or this bigger one? I needed this bigger one because I have to allow for the dough to rise. And the way to calculate that is you want to take 3 times your flour weight in grams, and that will equal the maximum height that you need in your vessel in milliliters for the dough to double in size if you wanted it to double, which is uncommon, but that gives you some headroom. So here's the example. 500 gram flour weight recipe times 3 tells me the milliliters I need if that dough were going to double in volume. 500 times 3, 1500. So I need at least a 1500 milliliter vessel or 1.5 liter vessel. This vessel happens to be 2000 milliliters or 2 liters. So I have plenty of headroom in this vessel. That's how you size it. Use that rule of 3 times the flour weight. So now I know my starting point. I have my dough in my stretch and fold bowl. I'm doing my stretch and folds. I'm doing my coil folds. The dough starts rising. Do I need to worry about that? You don't need to worry about that because it's never going to hit your target before you finish the stretch and folds. That would be incredibly uncommon. So do your stretch and folds. Then once your stretch and folds or coil folds are done, you're in the middle of bulk fermentation here. That's when you're going to carefully take your bulk fermenting dough out of your stretch and fold vessel and put it into your measuring vessel. And you're not going to touch this until it's done. So I carefully take my dough out. I put it in my measuring vessel. Now we can figure out what is the target percent rise that we're looking for. How do we do this? I take the dough temperature, and the dough temperature will tell me the target percent rise. I take my dough temperature, 70 degrees Fahrenheit, 21 degrees Celsius. I look at my chart. 70 degrees Fahrenheit, 21 degrees Celsius needs a 75% rise in the dough. How do I get that number? I know my starting line was 750 milliliters, so I take that starting line times 1.75. That's a 75% increase. 750 times 1.75, I think, is 1,312.5 milliliters. Computer, what's 750 times 1.75?
Good afternoon, Tom. 750 times 1.75 is 1,312.5.
1,312.5. So I mark that on my tape. I find that measurement on my vessel to the top of the tape to the best of my ability. That's my 75% rise. Now I walk away. I go do chores. I go watch TV. I'm not doing anything here. I'm not watching the clock at all. All I'm doing is watching the dough. And when that dough rises and hits that line, the top of that tape, 1,312.5 milliliters, that's a 75% rise. Bulk fermentation is done. Shape it. Pre-shape, bench rest, final shape, put it in the refrigerator for 8 to 16 hours, bake it the next day, it's perfectly proofed. Now, a lot of people ask questions and ask, how do you measure that ending volume? Because as the dough is rising, it domes up on the top. You can see that here in this example for sure. That's the natural way that this dough will rise. So what I typically do is you have 2 data points you can look at. Look at what's the milliliter marker where the dough is touching the side of the bowl, and then you look through the bowl and say, what would the milliliters be if I could lay something flat on top of the dome? And so you have those 2 numbers and basically split the difference between those. So in this example, if I have the side of the dough touching my vessel right now at 1,000 milliliters, and the top of the dome is at 1,100 milliliters, I'm going to call that 1,050 milliliters, where I'm just splitting the difference between the 2. Another way to think about it is if at that exact moment in time that dough liquefied, the sides would come up and the top would go down. So splitting that difference is very similar to using that liquefaction example. It has to be higher than the outside edge touching the bowl, and it has to be lower than the dome. Just pick the midpoint, it's close enough. Then people ask the question, they say, oh my gosh, I was watching TV, the dough kind of ran away from me. I didn't catch it right at the moment of 1,312.5 milliliters. Did I ruin my dough? You didn't. You have a window to let the dough go past these estimated percentage rises. But it's related to the dough temperature. And again, this goes back to the speed of fermentation is related to the temperature of the dough. So let's say, for example, in this case, I'm looking for a 75% rise in this dough at 70 degrees Fahrenheit, 21 degrees Celsius. That's a fairly cool bulk fermentation temperature. So you have a bigger margin of error on cool dough. So let's say I'm going for a 75% rise. This could go up to 80%, 85%. I mean, maybe even up to 90%. This dough would still be okay because it's relatively cool. With warm dough, 80 degrees Fahrenheit, 27 degrees Celsius, you have about a 5 percentage point margin. I'm serious. I mean, it is really tight. If this called for a 30% rise and you let it go to 50%, it's overproofed. You let it go to 40%, it's right on the edge of overproofing. Maybe you can go 30 to 35% rise to get it perfectly proofed. So that window, your margin of error depends on the dough temperature. Cooler dough, you can overshoot the target more. So we're almost there. Your dough has perfectly risen. You've done pre-shaping, bench rest, final shaping. The dough has gone into the refrigerator from 8 to 16 hours. And some people will say, wow, 8 to 16, that's a pretty large window. Go back to this chart. After 8 hours, the fermentation is largely done. I mean, you're down here at 40 degrees Fahrenheit, 4.4 degrees Celsius, very, very slow fermentation. So the difference between 8 hours and 16 hours is very minimal fermentation activity happening. So you have a big window on the back end of that refrigerator final proofing time, which is great if you're trying to work around a busy schedule. I've left my dough in the refrigerator for up to 3 days and baked it. As you start to go past 24 hours, the thing that you want to think about, because that dough is still very slowly fermenting, if you start adding days, instead of 1 day, you go to 2 days, 2 days, you go to 3 days, each day that you add in the refrigerator is a little bit, I'm going to make a gross generalization, it's a little bit like adding an extra hour of bulk fermentation. So your dough will continue to proof in the refrigerator, but you have a wide window. But the refrigerator temperature is an important part of this formula. So we've been really hyper-focused on our dough temperature during bulk fermentation and our percentage rise. What if your refrigerator temperature is too warm? I mean, this happens in the summer. You have kids going in and out of the house. They're opening the refrigerator. They're leaving it open for 10 minutes at a time. If you have dough in there and your refrigerator is warmer than you expect it to be, this chart doesn't get down to 40 degrees Fahrenheit or 4 degrees Celsius very quickly. It's going to stay a little bit higher than that. Your dough can overproof in the refrigerator because of the refrigerator temperature, not because of where you cut it off for final proofing. So those two things are closely connected. So what I suggest is when you take your dough out of the refrigerator to bake it the next morning, always take the temperature of your dough before you score it and bake it, because that will tell you if your dough actually went to sleep and got down here. Because I'm using this model based on the assumption that your dough temperature will hit 39 degrees Fahrenheit or 4 degrees Celsius in the refrigerator. If your refrigerator doesn't get down to that temperature, these percentages will be too high. Now, I made a video earlier this year called Post-Pandemic Sourdough for Busy People, and in the latter half of that video, I talk about how to adjust and calibrate all of these percentages. Your percentage rise in bulk fermentation, your refrigerator temperature, the amount of time that's in the refrigerator. If you want to really dial this in, I recommend watching the second half of that video. The link is in the description of this video, and it will tell you how to monitor and calibrate all those temperatures. So I use that term calibration because this is an essential step in the process. I wish that sourdough baking were as simple as just a piece of paper with 8 numbers on it. It's pretty close, but it's not foolproof. So what you need to be able to do is after you apply these criteria, you need to assess your crumb and determine if it's overproofed or underproofed. So you bake your loaf, you cut it open, you look at the bisection of the loaf, and then you should consult the video I have, How to Read a Sourdough Crumb, and there's a guide that you can print out, and you're going to compare your loaf to that guide, and it will tell you, does your loaf look overproofed or underproofed? So let's say, for example, in our scenario, our 70-degree loaf at 75% rise, let's say that looks a little underproofed. If that's the case, you want to repeat that process exactly, but I suggest going up in 10% increments. So the next time you want your percent rise to be 85% rise instead of 75% rise, you bake that loaf, you cut it open, you look at it, and you say, oh my gosh, 85% rise in bulk fermentation, my loaf is slightly overproofed. 75's under, 85's over. Wonder what would happen if we tried an 80% rise. So you bake it a third time. At the 80% rise in bulk fermentation, it's perfectly fermented, perfectly proofed. You make a note of that on this sheet and say, okay, my records now say at a 70-degree Fahrenheit dough temperature, I need to go to an 80% rise. It will repeat the same results every time. I mean, once you dial that in for a specific recipe, it is repeatable every time. That's the beauty of this method. It takes the guesswork out. Now, for people who've been watching my videos for years, you might look at this method and say, wow, this is really interesting, but this is a little different than the method Tom popularized back in 2020, which was called the bulkomatic system. The bulkomatic system is a technique where you have 9 criteria to determine when bulk fermentation is done. It's specifically based on the tartine recipe for that very warm temperature range around 80 degrees Fahrenheit or 27 degrees Celsius dough temperature. So there is one exception to this chart. On line number 1, if you're bulk fermenting at 80 degrees Fahrenheit, 27 degrees Celsius, that 30% rise is a good approximation, but you want to augment this chart with the incredible bulkomatic system. 9 criteria. Because the dough is fermenting so quickly at that dough temperature, things can go south in 15 minutes. I've seen it. So you can't rely entirely on the percentage rise. That'll get you in the ballpark, but then you need to ask the question, is it domed on top? Does it have bubbles on the side? Does it wobble when you shake it? What does it smell like? What does the window pane feel like? You need to use all your senses and all your tools as a baker to be able to bulk ferment dough at 80 degrees Fahrenheit or 27 degrees Celsius. Believe me, that is really expert level fermentation territory when the dough is at that temperature. So for dough fermenting at 75 degrees Fahrenheit or less, all you need to measure is the percentage rise and the dough temperature. If you're around 80 degrees or higher, you want to augment that with the bulkomatic criteria. So in today's example, we just fermented this dough at room temperature. We didn't try to control the temperature. And in our example, 70 degrees Fahrenheit, we did the 75% rise. And as I've been saying the whole time, you want to ignore the timing. This is really just to show the possible relative differences here because everybody's starter is different. But let's say you do this process 3 or 4 or 5 times and you keep really good records of this, and you're getting perfectly fermented dough at 70 degrees Fahrenheit with a 75% rise. And the guidance here says, in my kitchen, that would take about 12 hours. With my starter, let's say yours takes 10 hours, and it takes 10 hours every time you do it. This process becomes incredibly predictable when you repeat it like that. And you'll find that your fermentation times will be almost exactly the same at those same temperatures. So then people start to ask the question, wow, this is as predictable as clockwork. What if I actually manipulated my dough temperature? Then I can make more sourdough because I can get the timing to fit within my window. So if 10 hours is a bad time slot for you to work with between mixing the dough and shaping the dough, you could say, what if I sped that up to 75 degrees Fahrenheit to try to get it to happen faster? That's where people use proofing chambers. So here's an example. This is the Broden Taylor proofing box. This is incredibly popular. It's a great tool. This has a thermostat on the side, and you dial in what temperature you want your dough temperature to be at. So let's say we wanted to do it at 75 degrees Fahrenheit. I punch in 75 degrees, I put it in, put my dough in here, and it'll maintain that temperature. These things work perfectly. I also use this for the tartine method where I'm bulk fermenting at 80 degrees Fahrenheit or 27 degrees Celsius. That's way higher than my room temperature would ever be. So I bulk ferment my dough in here because it ferments faster, and I want that timing. I want a shorter time window when I'm making that dough. So these warm proofers are great, but there's also something really cool, which is a warm and cold proofer. Now, if you've seen my videos with Bob, the Sourdough for Busy People video, or my post-pandemic Sourdough for Busy People video, I use this incubator. This can warm or cool your dough. So think about this. Once you get this fermentation process down, where you literally can walk away from your dough, all you look at is the percentage rise, now you can focus on controlling timing, where you can make your dough work around your schedule. So if 10 hours isn't a good time window for you at 70 degrees Fahrenheit, 21 degrees Celsius, you could say, I want to lower my dough temperature to 65 degrees Fahrenheit because then I can stretch out the time. You can do that in here. These are warmers and coolers. You basically mix your dough. After your stretch and folds, you put your dough in here. You specify what temperature you want your dough to be at, and you walk away. These things work like a clock. I mean, once you get this process down, if you set this at 65 degrees Fahrenheit and it takes 12 hours, it'll take 12 hours every time. I mean, it's unbelievable. Because when you control temperature, you control time. And when you control time, you can make more sourdough bread because you can fit it into your busy schedule. These are the future of sourdough baking. I'm telling you, for home bakers, these warm and cold proofers give you the ability to make dough on your schedule. If you're interested in that concept, watch my videos, Post-Pandemic Sourdough for Busy People or the Sourdough Brothers for Busy People. Thanks again for watching this video, and good luck on your sourdough journey.